In square ABCD, connect the corner A to the opposite side DC, dividing it into lengths of 1 and 2. Repeat this procedure for the other 3 corners of the square. The result will be 4 lines that bound a square shown in blue. The question is, what is the area of the square in blue divided by the area of the square ABCD? In other words, what fraction of the square ABCD is shaded in blue? You can also solve the general problem where we replace 2 with the variable x. Pause the video if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. One way to solve this problem is by considering the area of the parallelogram shown in green. We'll calculate its area in 2 different ways. One way to calculate the area is by taking the base of x and the height of x plus 1. The area is then the product of the base and the height, which is equal to x multiplied by the quantity x plus 1. But there's another way that we can calculate the area of the parallelogram. We'll take the height to be the length s of this square, and we'll take the base to be the hypotenuse of this right triangle. We can calculate the length of this hypotenuse using the Gogu theorem. It'll be equal to the square root of 1 plus the quantity x plus 1 squared. We then take the product of the base and the height to get another formula for the area of the parallelogram. We thus have 2 different ways to express the area of the parallelogram, so we set those equal to each other. We'll then solve this equation for s. We want the area of this square, which will be equal to s squared. We then want to divide it by the area of the entire square ABCD. We thus take the ratio, we'll then cancel out the x plus 1 squared terms, and that'll leave us with the fraction of the square that's shaded in blue. We can then solve for particular values. For example, if x is equal to 2, we can easily calculate that the fraction that's shaded in blue will be equal to 2 over 5. And that's the answer.